looking mass class, welcome you to this amazing YouTube channel. Apology for being absent a few days ago, and I hope my apology is accepted. So today we'll be looking at set notation. But before I start, please, if it's your first time of coming across this channel, kindly hit the like and subscribe button at before or at the end of the class. So let's start. The first set notation to note here is simply known as element of. Now, element of is represented by this letter resembling what? A capital letter what? E. Okay, so if I say y is an element of x, so this sentence here can be represented mathematically by saying y is an element of x, because you have identified element of as this capital letter what? E. So y is an element of x. So if I also say, let me call this the note 1. Then if I also say y is not an element of x, that can also be represented by this, but with a slash across the word in notation. How this is clear. Element of is represented by this sign. So if I give an instance by saying y is an element of x, how do I represent this mathematically? It can be represented by this. Y is an element of x. If I say y is not an element of x, it can be represented by what? By this, with a slash across the word in notation. Now the second notation to note here is known as union of sets. Now, union of two or more sets is the combination of elements in the set without repetition. Again, union of two or more sets is the combination of elements of the set without repetition. It is denoted by this sign, but not boldly this. So union, this is union sign, not boldly this. It's not. It doesn't have to be thick. Just slant like this, not thick, just light like this. Okay. So now let's give an instance here. Given sets A and B, right? We can say A is, let's say, 1, 2, 3, 4, 5, and 6. I'll say set B is 7, 9, 8, 6, 5, and 4. Look at this. Before that, we know that x is an element of A, and also x is an element of B. Right? This is x such that x is an element of A, and also x is an element of what? B. So for us to represent these two here by getting their union, now we say union is the combination of the two elements, right? The two elements in the set without repetition. So therefore A union B is equals to, now I'll combine this and this together. So I'll have 1, 2, 3, 4, 5. Now there is 5 here. There's also 5 here. So I'm not expected to write 5, 5. It's just simply what? 5. So 5, then 6. Also without repetition, 6 is here. 6 is also here. Then we go to 7. Then we have 8. We have 8 and we have 9. 8 and 9. So this is the result of combining these two elements together. Are we following? So the next one is known as, permit me to wipe off this part. Okay. So the next one here is known as intersection of sets. Now, intersection of sets as a result, intersection of two or more sets as a result that contains only the common element in the two word set. Okay, so it is represented by this sign, not boldly tick. So this is intersection sign, this is not intersection sign, this is a boldly N and this is a light N. Are we together? So let's give an instance again. Given set A to be equals to 2, 3, 4, 5, and 6. Then set B to be 1, 3, 7, 9, and 6. And we are asked to find the intersection of these two sets. Of course, if I take in an instance by saying A is an element of A and B, just like this one here, I'm still going to arrive at this same thing. Okay, so therefore my A intersection B will be equal to what is common to the two sets. That's what they call intersection of sets. The elements common to the two sets are 3 is common, then what again? 6 is also what? Common. So I've arrived at this particular word 3, 6 as the common element in the two sets here. So the last here is we have the complement of sets. The complement of any sets, let's say elements K, let's say set K rather. Okay, let's say let's say set K. As every element in the universe set but except what? K. That's what complement is. You understand better now. Let me explain mathematically. Now, it is always denoted by K complement or this. So I say it contains every element in the universe set except those of what? K. So that means I can give a formula like this. U minus K except those of K will be equal to what? Complement of what? Of a set. Of that set K. Are we following? So now, take for instance, we are given set A. Okay, before that, let me give one instance here. A given set, inverse set here. A, B, C, D, and E. And we are given set A to be equals to, okay, let me complete this one to E, F, G, H. Please, are we following? Then if we are given set A to be A, B, C, D, and we're given set B to be equals to E, F, G. Look at it. Now, we now asked to find the complement of these two sets, whether it is by union or what? By intersection of what? Of sets. So, what I mean by union or intersection of sets is this. If you are asked to find A complement intersection B complement. Now, you need to find the A complement first and also the B complement first. So my A complement here is simply going to be equals to what? Now, like instance of K, what is here? You remove it from this universal set to give the complement of that set. Are we together? What is here? You remove it from here to give the remaining value. So if you look at A, now A has A, B, C, D. So if you remove A, B, C, D from this place, you have left is what? E, F, G, H. E, F, G, and H. So same thing applies to what? To B. Remove what is there in this universal set, that is E, F, G, E, F, G. So you'll be left with A, B, C, D, H. A, B, C, D, H. So we are now asked to find A complement intersection B complement. So don't forget, intersection means what is common to the two sets here. Okay, so what is common to these is just going to be H. That's the common element in there. Okay, guys, I'm going to stop here for today. Please, if you have any question on this particular set notation, kindly drop in the comment section and I'll continue from this in my next class. I'll see you guys in my next class. Bye for now.